In late March 2026, NASA paused the Lunar Gateway, the moon-orbiting space station that was supposed to be the centerpiece of the long-term lunar exploration plan under Artemis. It looked like a sudden decision, but it wasn't. For years before that announcement, the cracks had been showing. In cost reports, in mass numbers, in inspector general audits, in budget proposals quietly threatening the program a year ahead of time. The space community could see something was wrong. Most of the public couldn't. This is the story of how a major NASA program, billions of dollars, multiple international partners, real hardware already built, came apart in public, in slow motion, before being officially paused. The Lunar Gateway was designed to be the first permanent crewed space station beyond Earth orbit. A small modular outpost that would serve as a staging point for Artemis missions, an international science platform, and the long-term anchor for sustained human presence in lunar space. It was meant to be the next chapter of the ISS partnership, extended into deep space. The first two modules, the Power and Propulsion Element, or PPE, built by Maxar in California, and the Habitation and Logistics Outpost, or HALO, structurally welded in Italy by Thales Alenia Space and completed by Northrop Grumman in Arizona, would launch together as a single integrated spacecraft on a Falcon Heavy. From there, they would spend about a year spiraling out to lunar orbit using solar electric propulsion. Additional modules would follow on subsequent missions: an international habitation module from Europe and Japan, a Canadian robotic arm called Canadarm3, an ESA refueling and communications package, and an airlock module from the United Arab Emirates. Pieces from a half-dozen partner agencies assembled in lunar orbit over multiple flights. All of that depended on a particular orbit. Gateway was designed to fly in something called a near-rectilinear halo orbit, an unusual, stretched-out loop around the moon that's fuel-efficient and reaches close to the lunar South Pole. But no spacecraft had ever actually flown one, so NASA sent a small pathfinder ahead to verify the orbit would work, a microwave-sized CubeSat called Capstone, which arrived at the moon in November 2022 and held the orbit for years afterward. With the orbit confirmed, Gateway's plan moved forward. By April 2025, the HALO module was finished and shipped to Northrop Grumman's facility in Arizona for final outfitting. The PPE was being prepared for integration. Partner contributions were being built in Italy, Canada, Japan, and several ESA member states. On paper, Gateway was on track to lunar orbit. In reality, it had been quietly in trouble for years. The first sign came in 2020. NASA's own Office of Inspector General published an audit of the Gateway program and found that the schedule and cost projections weren't holding up. The specific finding: NASA was changing the program's requirements after the contracts had been awarded. By the time NASA committed to its initial capability milestone, getting PPE and HALO integrated and ready for launch, the price tag for just that piece had grown to $5.3 billion. The target launch date kept moving, from 2024 to 2025 to no earlier than December 2027. Then came the mass problem. In 2024, the Government Accountability Office reported that the combined mass of PPE and HALO had grown about 1,312 kilograms, roughly 2,900 pounds, over the budgeted figure. Mass growth doesn't look catastrophic on a single chart, but it compounds with everything else a program is trying to hold together. The financial pressure showed up on the contractor's books too. Northrop Grumman, the prime contractor on HALO, took approximately $100 million in charges against the program. That kind of overrun signals a program that turned out to be fundamentally harder to execute than expected. And there was a technical problem nobody had wanted to talk about publicly. The HALO and IHAB modules had developed a corrosion issue, material degradation in the hardware that the program would have to repair or work around. The full extent wasn't disclosed at the time, but it was a real engineering setback on modules that were supposed to be flight-ready. In May 2025, 10 months before Gateway was officially paused, the new administration's preliminary fiscal year 2026 budget proposed cutting Gateway entirely, along with retiring SLS and Orion after Artemis 3. The proposal didn't pass at the time, but it was a clear public signal that the program's status was no longer secure. It was the result of years of compounding pressure, engineering pressure, schedule pressure, cost pressure, and political pressure, all converging. On March 24, 2026, NASA held a strategy event it called Ignition, a public unveiling of the agency's revised approach to human exploration under new leadership. Among several major announcements, one stood out. The Lunar Gateway would be paused. The framing matters. NASA did not formally terminate the program. The agency's official position was that Gateway was on pause, that hardware and partnership contributions would be reassessed for possible repurposing, and that the orbital outpost might still return in some form at a later date. In practice, the announcement signaled the end of Gateway as a near-term program. Partner agencies were notified that their Gateway-specific contributions would not be needed on the timeline they had been planning around. The space community read it accurately as a cancellation, regardless of the official wording. The strategic logic was the surface-first pivot. Instead of investing in a lunar orbital outpost, NASA would redirect its long-term lunar resources toward a sustained surface presence, a permanent base on the Moon, built up over roughly 7 years across dozens of missions and at a projected cost of about $20 billion. Removing the orbital intermediate layer, the agency argued, would simplify the architecture, reduce overall mission complexity, and free up budget for surface infrastructure. There was also a competitive overlay. NASA explicitly framed the new direction against an increasingly aggressive Chinese lunar program. China has targeted a 2030 crewed moon landing, and argued that a more focused, surface-oriented architecture would help the United States stay ahead. And there was a striking piece of timing. The ignition announcement was made on March 24th. 8 days later, on April 1st, Artemis 2 launched on schedule. The first crewed Artemis flight, carrying 4 astronauts on a free return trajectory around the Moon. NASA was simultaneously executing a major success and contracting one of its core programs. The pause raised a basic practical question. What happens to the hardware and the commitments? By March 2026, a significant amount of Gateway was already physical. HALO had been at Northrop's facility for almost a year, undergoing outfitting. PPE was further along in fabrication at Maxar. Canada's robotic arm, Canadarm3, a roughly $1 billion contribution from the Canadian Space Agency, was deep into development. ESA and JAXA had been building toward the International Habitation Module. Across partners, the combined investment was billions of dollars of metal, electronics, and contracts. None of that hardware was officially scrapped. NASA's stated position was that hardware, where applicable, would be considered for repurposing, possibly toward the new surface-focused architecture. But the practical questions were immediate. A moon-orbiting habitation module isn't easily redesigned into a surface habitat. A station-keeping power module isn't naturally suited for a surface base. International contracts written around Gateway's specific requirements don't transfer cleanly to a new architecture that wasn't yet fully defined. International partners had been preparing for the possibility since the May 2025 budget proposal, but the actual ignition decision, What would be cut, what the new architecture looked like, and how their contributions would be repurposed was learned alongside the general public. The simplest summary is this. As of the spring of 2026, billions of dollars of flight hardware and partner commitments existed for a program with no clear destination. NASA's pause framing left a path back, but no schedule and no concrete next step. Step back from the Gateway story specifically, and the broader picture is more complicated than the headlines suggest. Not everything about Gateway's role actually went away. Orion, the crew capsule the entire Artemis program depends on, still has the same propulsion limitations that made the near-rectilinear halo orbit the right choice in the first place. Orion can't reach a close orbit around the Moon and return. It physically has to use a high orbit, like the NRHO. So even in the new surface-first architecture, Orion still parks in that orbit and meets the lander there. The orbit Capstone proved is still where every crewed Artemis mission has to converge. The bigger structural question for the new architecture is launch cadence. The lander concepts currently under contract, SpaceX's Starship HLS and Blue Origin's Blue Moon, require massive propellant deliveries in low Earth orbit before they can head to the Moon. In Starship's case, that's somewhere between 10 and 20 tanker launches per mission, just to fuel a single lander. I covered how that orbital refueling actually works and the engineering challenges involved in a previous video, link in the description. The reusable lander concepts that would lower that launch tempo aren't built yet, and the new plan calls for far more frequent surface missions than NASA has ever sustained. A cadence problem the program will eventually have to solve before the cost per mission drops enough to support that pace. There's also a pattern worth naming. Gateway is not the only major NASA program to be closed in early 2026. The Mars Sample Return Mission, a flagship Mars effort with international participation, was effectively defunded in a January 2026 spending bill, also under 2026 budget pressure. Again, there's a dedicated video on this topic I made recently. I'll leave a link in the description. Both Gateway and MSR came out of the same fiscal environment, the same simplification logic, and the same political climate. That doesn't make the new direction wrong. Simplification can be the right call when a program has lost its way. But the cost is real, and the cost lands on hardware that was already built, partners who had already committed, and a workforce that had been planning around a different future. The Lunar Gateway is, officially, still paused, and could, in theory, still return. Whether that ever happens is a real open question, and the honest answer is that nobody knows. NASA's stated position leaves the door open. The practical reality of restarting a paused international program of this size, remobilizing partners, refunding contracts, reconnecting hardware to a now different architecture, makes it much harder than starting fresh. The longer it sits, the smaller the chance it returns in anything like its original form. A finished habitation module sits in a clean room. Whether it ever flies depends on a plan that hasn't been built yet, and on whether the program meant to replace it can survive the same pressures that ended this one.